All right, we have a few minutes. If you have any questions, maybe this is the time. All right, just to test, can somebody confirm you can hear me? Can you hear me?
Yes, miss.
Thank you so much. And now, can you see my computer? Can someone confirm you can see my computer?
Yes, we can.
Okay, great. Excellent. So we have 2 minutes, then we are going to start, okay? Are there any questions before we start? Anything? All right, it is 4 o'clock. Shall we start? Hello and welcome. Thank you so much for your participation. I appreciate your participation. Before we start, are there any questions? Anything? Okay, you can ask questions during my demonstration by typing your questions on the chat area, or you can directly speak up. Okay. So today we are going to do statistics, descriptive statistics, and probability using Excel. The first question is about Facebook survey. The question asks you to find the average and median hours online per week and the number of friends in the sample using Excel functions. You are asked also to compute the mid-range and compare all the measures of location. Okay. So this is the question. So open the Excel file. And then go to 4.2 worksheet. This data is about Facebook survey. You have student number, and you have gender, hours online per week, friends. So the question asks you, what is the average hours online? Okay, so in Excel, you type in equal average. Then you select data from C6 to C28. Press Enter key. So that is the average online time. Next one, what is the median? Median, you use Excel, MEDIAN, median. Opening, Opening bracket, select C6 to C38, closing bracket, press Enter key. So that is the median. Okay. And next, you ask for the mid-range. Remember what is the mid-range? Mid-range is maximum plus minimum, and the result divided by 2. So to do that, I will figure out what is the maximum number and what is the minimum number first. I'm going to put those two numbers here. For maximum, typing equal max, opening bracket, then select C6 to C38, that is maximum. Similarly, you do the minimum, typing equal min, C6 to C38. So after that, any questions? The mid-range, you use maximum plus minimum. Maximum plus minimum. G3 plus G4. And then divided by 2. Oops. That is the mid-range. And the mode. Remember what is the mode? Mode is the most frequently happened number. Which number appeared the most? So we use Excel to find out MODE. Opening bracket. Select C6 to C38. Okay. So any questions? Next, we are going to do the same thing for number of friends, column D. So what is the average number of friends? Quick cell J5, type in average, equal average, and then select from D6 to D38, closing bracket, this enter key. Okay. And then median, MEDIAN, D6 to D38. Again, mid-range, you need to find the maximum number. So equal MAX. What is the maximum number for column D? And then found the minimum number for column D, MIN. Please interact with me. Any questions, feel free, okay? Oops. Now I calculate mid-range. It is maximum plus minimum divided by 2. And the next one, mod. So type equal MODE. And then select from D6 to D38. All right. So that is the descriptive statistics. Okay, average, median, mid-range, mod. Okay. Those numbers also has a name. It's called measures of location. So when we say measures of location, we refer to mean, median, mod, mid-range. Okay. Are there any questions? Okay, next, we are going to use data analysis tool to get some descriptive statistics for hours online and for friends. Okay. All right. So to do that, make sure you click data on the ribbon, and then you have data analysis. If you do not have data analysis, and if you are using Windows, you go File, Options, after that, click Add-ins. You click Add-ins, then you click Analysis Toolpack. After that, you click Go button here, and then you click OK button. So after this procedure, you should have data analysis. This is for PC users. If you are Mac users, you go to on the top, you select Insert, and then choose Add-ins. Okay. Alternatively, you can Google the keyword how to add data analysis in Excel. Okay, use Google to find out. So anyway, I already have data analysis. So I click data analysis, then select descriptive statistics. Click OK button. After that, select input range. So I want column C. So from C5, I also include the label heading. So labels in first row. And then make sure you check out summary statistics, and output range. Output range, you put output here in F16. Then you click OK button. So this is the descriptive statistics. Okay, you can compare. So the mean is 6.25. See, we already calculated the mean 6.25. Okay. And the median is 6. See, we also did median 6. Mode is 4. See, it's consistent with our calculation. Okay, any questions? And now repeat the same procedure for friends. So you go to data analysis, then descriptive statistics. Click OK button. After that, select input range from D5 to D38. Make sure you select labels because I started from D5. Labels in first row is checked. Output. I want the output here. Okay, I want this is the output. And make sure you check out summary statistics. Then you click OK button. Okay, so now let's compare the result with our calculation. So the mean 176.97. See, we did that. The median 120. And the mode is 90. The same results. Okay, but using data analysis, you get more statistics. You get standard error, standard deviation, sample variance, etc. Okay. Are there any questions? All right. So let's move on to next question. Question 2. Suppose that you are interested in the number of arrivals at the drive-up teller window of a bank during a 15-minute period on weekday mornings. An analysis of historical data shows that the average number of cars arriving during a 15-minute interval of time is 10. The percent probability function with lambda equal to 10 applies. Now the question, what is the probability of 5 arrivals in 15 minutes? So this should be a question mark. What is the probability of 5 arrivals in 15 minutes? And now using Excel, we go to the percent distribution here. And you are given the average lambda equal to 10 arrivals per 15 minutes. And the question asks you for what is the probability of 5 arrivals within 15 minutes? That is the question. Okay. So, and another question, what is the probability at least 5 arrivals? Okay. So let's do the first question. Probability of 5 arrivals. Okay. I will put the result here. Okay, because I leave this space to do something else. The formula is equal Poisson, Poisson out dist, opening bracket. X is 5, because the question asks you 5 arrivals. Mean is the lambda that is given. Average, you have 10 arrivals. Cumulative is false, so 0 means false. Why it is false? Because the question asks you exact the probability of 5, not smaller equal to 5, not greater equal to 5, exactly 5. Okay, so it is not a cumulative. That's why it is a 0. Okay, and then you get this result. Okay, so the answer is the probability of 5 arrivals within 15 minutes is 0.0378. Okay. And it looks like this worksheet also asks you what is the probability of 0 arrival, what is the probability of 1 arrival, what is the probability of 2 arrival, etc. until what is the probability of 10 arrival. Okay, we have to answer all of those. So now let's do the first one. What is the probability of 0 arrival? This time I'm going to use the Poisson formula, and I will use absolute cell reference because I am going to copy down the formula. Okay, so watch out. We have equal Poisson, Poisson dot dist, opening bracket, x. This is my x. I am using cell reference because I want to copy down the formula. The mean is 10. I am using cell reference because I am going to copy down the formula. And I have to translate this cell reference to absolute cell reference, means by press F4 button if you are PC users. So $C, $6. The reason is this number is not changed. This number is fixed for all the numbers. This is the average. It is a fixed number. Okay. Cumulative, no. I want to find exactly 0 arrivals, exactly 1 arrivals, exactly 2 arrivals. So cumulative, no. Now, use the fill handle, copy down the formula. See, the probability of 5 arrivals. This number is exactly the same as I did at the first place. Okay. So now if you say the question, what is at least 5? At least 5 means, what is at least 5? At least 5 means 5, 6, 7, 8, 9, 10. You add all these numbers together. That is at least 5, right? So that is the one way to do it. At least 5 equal to sum of from 5 plus 6 plus 7 plus 8 plus 9 plus 10. That is at least 5. Okay, at least 5. This is one way to do it. Another way to do it, at least 5. So I'm going to use the one note here. I'm going to type in here. at least 5. Okay? At least 5 equal to, so it is the same as the probability of, maybe I'll do this. What is the probability of at least 5? This one is the same as the probability of x greater equal to 5. Okay, x greater equal to 5. And it is equal to 1 minus probability of x smaller equal to 4. Okay, so this is another way to do it. I just give you the hint here. Okay. Oops. Go back to my Excel. Okay, so we get at least 5. Okay, another way to do it, maybe equal to 1 minus probability percent. GOI SS on percent dot DIST. Mean is 10, or X is 4. Mean is 10. Cumulative, yes. 1 minus at least 5 sum of this one I will doubt, because at least 5, maybe 10, maybe there are more, 11, 12, etc., etc. So I wouldn't use this one, the sum formula. So I would propose at least 5 equal to 1 minus x smaller equal to 4. So this one should be correct. Okay, for at least 5. So use this one here. At least 5 equal to 1 minus probability x smaller equal to 4. 1 minus probability x smaller equal to 4. Okay. And then use this formula here. So this is the exact formula. Control C, I will copy it here. Okay, this is the formula I type in. And what is the result? The result is 0.9 something. 0.97075. Okay. So this is this question. Any questions? Next question. A block club cafeteria sells a popular on-tap drink. When the stock of this drink drops to 20 gallons, a replenishment order is placed. The store manager is concerned that sales are being lost due to stock outs while waiting for an order. It has been determined that demand during the replenishment lead time is normally distributed with a mean of 15 gallons and a standard deviation of 6 gallons. The manager would like to know the probability of stock out. That is, what is the probability x greater than 20? So first, I will analyze this question, and then I will use Excel. Remember, when you do normal distribution, the normal distribution is bell-shaped curve. The area under this bell-shaped curve is 1. Okay, so the area under bell-shaped curve is 1. And the Excel is always based on area to the left of the point. area to the left of the point. But our question is ask you, what is the probability x greater than 20? So you ask the area is here. Greater than 20 means on the right-hand side of this x. So what would you do? You use 1 minus the area on the left. The result you will get the area to the right. Okay, so the question becomes the probability of x greater than 20, that equal to 1 minus the probability of x smaller equal to 20. Translate into Excel formula, so equal 1 minus normal distribution, norm.dist, and then typing x is 20, and 15 is the mean, 6 is standard deviation, 1 is a parameter showing that it is a cumulative. Okay, so that is the analysis. Now let's use Excel to do it. We don't have a separate worksheet. Maybe I will just do it on the side here. Okay, so typing the title, this is the block club.
Sorry, Professor, I think it's in 5.38.
Oh, thank you so much. Thank you so much. Yeah, we do have a worksheet for this one. The last one, we don't have worksheet. Thank you so much, right? So the question asks you, what is the probability of x greater than 20? That is the question. Okay. This gives you the hint. Solve what is the probability x smaller equal to 20. Okay. So you type in equal norm.dist. X is 20. Mean is 15. Standard deviation is 6. You could use cell reference here. Okay. And then cumulative, yes. So this is a smaller equal to 20. And then greater 20 equal to 1 minus smaller equal to 20. Okay. Alternatively, you directly type in the formula I showed you in my OneNote here. You directly type in 1 minus norm.dist. I'm going to show you now. Equal 1 minus norm.dist, opening bracket, x is 20, mean is 15, standard deviation is 6, cumulative is 1. You directly use this formula. Okay, and you get this result. Okay. Looks like you are also need to calculate the z-value, although the question didn't ask you in the Word document, but you're supposed to know. Okay, remember what is the z-value? Remember what is the z-value? Z equal to x minus x bar divided by standard deviation. Okay, so that is the z-value. Now I'm going to compute the z-value for 20. Z equal to x is 20, minus x bar is 15 divided by standard deviation. That is the z-value. Okay. So that is this question. Okay. Let's go back to check. Yes, this is this question. Okay. Any questions? All right. So next question, question 4. We have a lot of questions here. A, B, C, D, E, F, G. Wow. All right. So let's do step by step. Let's read the question first. Using data in Consumer Transportation Survey, develop a contingency table for gender and vehicle driven. Then convert this table into probabilities based on A, B, C, D, E, F, G. So now let's go to the table. This is the table. Okay. Are there any questions? I don't want to miss any question. Oh, now I got a question. Thank you so much for your question. What is the difference between putting 0 and false? No difference. 0 equal to false. Okay, so no difference. 0 is the same as false. No difference. Thank you for your question. Okay. Okay, so now this one, we need to use pivot table to summarize the data first. Okay, so click anywhere inside the table and then go insert pivot table. Click existing worksheet and then maybe put the location here. Click OK button. So after that, the question asks you vehicle driven and gender. Okay, so you put vehicle driven, click and drag vehicle driven, put it into the rows, and then click and drag gender into column. After that, you click and drag vehicle driven into values. Now you get this nice summary table. Okay, so for example, this number 16 means there are 16 females driving car. And this number 4, oops, not this one. This number 4 means there are 4 female driving truck, okay, etc. And the total is raw total, 22 is the raw total for car, 29 is the column total for female, etc. Okay. So now, once you have this table, let's answer the question. Question A, what is the probability that a respondent is female? Question A, what is the probability respondent is female? So how many total female? 29. How many grand total? 50. So you use 29 divide 50. That is the answer. So next, question B. Maybe I will put the result. Put the result here. So that is question A. And then question B. What is the probability that a respondent drives a SUV? So you look, how many total SUV? 15. What is grand total? 50. So the answer is 15 divided by 50. Okay. So next question, question C. What is the probability that a respondent is male and drives a minivan? Male and drives a minivan. This guy here. male and drive minivan. Do you agree? There is only one person is male and drive minivan. So the probability is 1/50. 1/50. And question D, what is the probability a female drive either a truck or a SUV? Okay. So a female drive either a car drive either a truck or SUV. So there are nobody drive truck female. A female drive either a truck or an SUV. So there are 5 drive SUV. Nobody for female drive truck. So it is just 5/50. 5/50. So next, question E. If it is known that an individual drives a car, what is the probability that the individual is female? This question is a conditional probability. Okay, an individual drives a car, so you're only concerned about the car. Don't look at anything else. Just look at the car. The number I highlighted. Just looking at the number I highlighted. Now answer what is the probability? It is female. Okay, so female is 16/22. Why I do not use 16 divided by 50? Why not using 16 divided by 50? Because it is a conditional probability. Because it is said, given a person is driving a car, means you only concerned about the car, no minivan, no SUV, no truck. Okay? So this is the answer, E. And then F. Given that individual is male, what is the probability that he drives an SUV? So this time, given a person is male, so you're only concerned about male, the number I highlighted. Given a person is male, what is the probability he drives an SUV? So 10/21. You're only concerned about male, not female. Okay, so the answer for F is 10/21. Okay. So this is F, and then question G, we don't have formula. You do by yourself. Okay, just use the definition. What is are independent? 2 variables are independent. Okay, I will give you the answer. It is no, they are not independent. Okay. To dig deeply on question G, you are going to use the hypothesis test for chi-square test. Okay, that is outside this range. All right, any other questions? Any questions?
Yes, miss.
Yes, please.
How can we know that which range should each value be placed in when you create a pivot table?
Good question. Thank you so much. The question is, when I create a pivot table, how do I know? Okay, I will maybe draw a diagram here. Thank you so much for your question. That is commonly asked. That question you need to practice But first, you need to have a conceptual understanding. Otherwise, how do you take action? Okay, so I will write down the notes here. Remember, when you create a pivot table, and then you have something like column. Okay, something like column over here. And then you have something like rows, ROW, rows. Okay, and then you have something like sigma values. And the question is, how do you know which one put where? Okay, so for example, this one asks you to for gender and vehicle driven. And we know we have different vehicles. We have car, truck, SUV, etc. So you want to, the result looks like this. Remember, if you want the result, see, we have car, minivan, SUV, truck. So this is the row label. That's why when you do the pivot table, the row, you need to put vehicle driven here. Vehicle. Okay, put vehicle in the row, and the column. Remember, when you see we have male, female, that is the column. See, female, that is the column label. So you put the gender here, G-E-N-D-E-R, gender. Okay, and suppose the data is not based on gender. The data is based on first year student, second year student, third year student, fourth year student. You put that number here so that you put the category. Okay, and then the sigma value, you want to count how many people drive SUV, how many people drive truck, based on female or female. So that's why under the sigma value here, you put the count, you move the vehicle. Okay, vehicle. Okay. V-E-H-I-C-L-E. You move the vehicle here and make sure it is count. C-O-U-N-T, count, because you do not want to do the average. You do not want to do the maximum, minimum. You just want to count how many people drive car, how many people drive SUV. Okay, and this part need practice for pivot table. And our lab test 100% will have a question about the pivot table. So make sure you are very comfortable with that. And how do you practice? You redo the lab I am doing now. Make sure you feel comfortable. Including the previous lab, I also used the pivot table. Remember, you redo those labs until you feel you are comfortable. For example, create a pivot table without looking at my video recordings. Okay, thank you for the great question. Any other questions?
Oh yeah, one more question. For 4D, it's asking what is the probability that a female responded. So we're going to be out of 5 out of 29.
For the D. Okay, thank you again for your question. The question is for D. What is the probability to drive either a truck? See, what is the probability a female drive either a truck or an SUV?
Yeah,
so
so we're going to be out of 29 since it's asking female responded, or would it be still out of 50?
So female driving a car, or what is the question? Female driving a truck or SUV, either a truck or SUV. So 5 plus truck, but 0 truck. So that's why it is 5.
No, I'm wondering why it's 50 instead of 29.
Good question. Because this is not conditional probability. This is general probability. If you want to get 5/29, the question would be asked this way. Given the individual is female, what is the probability this person drive SUV? In that question, you use 5/29. Okay?
Oh, okay, thank you.
Yeah, you're welcome. Thank you for your questions. Okay. Any other questions? All right, last problem. We are done for this lab. This is pizza delivery, okay? The average, the distribution is exponentially distributed. It is not normally distributed. It is not percent distributed. It is exponentially distributed, okay? And the mean is 20 minutes. Now, question A, what is the probability the delivery time greater than 30 minutes? Question 2, what is the probability? By the way, the proportion is the same as probability. What is the probability within 20 minutes? So first, I'm going to analyze this question. Then I'm going to use Excel to do it, okay? And the question asks you, what is the probability exceed 30 minutes? Means, what is the probability x greater than 30? X greater than 30, okay? In Excel, it is usually based on smaller equal. If you have probability greater, you use 1 minus probability of x smaller equal to 30. Remember complement event, complement rule, okay? And then this is exponential. So you use expon.dist, that is exponential, okay? When you use exponential, there is a parameter called lambda. Lambda equal to 1 divided by mean. Mean is 20, so lambda equal to 1 divide 20. So that is question A, okay? So now let's do Excel for question A. And this question, there is no worksheet. Maybe you can just do something on the side of question 5.16. So you may be typing this is 5.42 question, okay? Question A asks you, what is the probability? Okay. So you type in equal 1 minus expon.dist. And then x is 30. Lambda is 1/20. Cumulative, yes. And you get this number. So this is the formula. Okay, it is also on my notes here. This is the formula. Okay, that is question A. And question B, what is the probability smaller equal 20? This is easy. You directly use expon.dist. X is 20, lambda 1/20. Cumulative, yes. So you directly type in this formula because the question asks you smaller equal. Okay, you get this number. All right. So in summary, what we did in this lab, we did descriptive statistics using Excel, okay, mean, average, mid-range. We also use data analysis, TORPAC to get descriptive statistics. And we use pivot table to analyze data to answer probability questions. We also use normal distribution, percent distribution, and exponential distributions. Okay. All right, so that's all for this lab. Are there any last minute questions? I'm going to take attendance, okay, before I let you go. So I'm going to take attendance. All right, so I downloaded the attendance. That's all for today. Thank you so much. The recording will be posted on Sakai. Okay. Good night. I'll see you next time.